All right, so let's look at concavity and how all that relates to the rate of change. We know the second derivative measures how the first derivative changes. So the greater the magnitude of the concavity, that means the faster the rate of change. So here's a curve. Over here at P, I know I've got a positive slope. So I know it's increasing, but the curve is concave down. So it's going to be increasing at a decreasing rate. This one at Q, it's decreasing, but it's still concave down. That does not mean it's decreasing at a decreasing rate. It's actually now decreasing at an increasing rate. Reason? Same as velocity, think of it as velocity and acceleration. When the signs are the same, it's getting faster. So in the first one, the signs are different, so therefore it must be slowing down. So it's at a decreasing rate. This one here at R, it's decreasing. They're opposite in sign, so therefore it's decreasing at a decreasing rate. They're both positive, so it's increasing at an increasing rate. Right? So essentially, if the signs are the same, it's at an increasing rate. If the signs are different, it's at a decreasing rate. So let's look at some interesting graphs here. Here's a graph. It also comes from a very excellent junior textbook. It's a graph of people per hectare versus petrol consumption, and it's simply saying, well, what can be concluded about the petrol consumption? Now, whilst back in year 9, wouldn't have known about the derivatives, basically it's decreasing at a decreasing rate because it's going down, so it's negative first derivative, but it's concave up, so positive second derivative. Signs are different, so it's at a decreasing rate. Here's one, autumn, which is where we are at the moment. Look at the temperature graphs. So one's the maximum, one's minimum temperature, but they're very similar graphs. But how does the temperature change? Well, at the start of autumn, look at the start of autumn, which of course our autumn starts in March, very good. So look at March, and it's decreasing at an increasing rate. However, the further you get into autumn, yes, the temperature is still decreasing, but now at a decreasing rate. It doesn't drop as dramatically. That's why you get those summer colds when you change from summer to autumn, because the temperature drops really quickly. But further you get into it, you get more used to the colder temperatures and what have you. This last one, last year, on March the 22nd, we had we called it shutdown at the time. It's now been changed, the word they seem to be using is lockdown now, but anyway. There's the graph where it all started 12 months ago. Okay, it went up. Now, given that it takes about 5 to 6 days for symptoms to show, do you think the measure has been effective? Remember, we started at the 22nd of March. So we're really towards the end of the graph here. 22nd of March, and then going to the end. Well, 5 days later, there does appear that an inflection point in the curve has occurred. So therefore, it's changed to concave down. So it's increasing, but its second derivative is negative. So it's increasing at a decreasing rate. And that was the whole goal. On the news and that, they all talked about flattening the curve. You know, we want to flatten the curve, which of course is impossible. Because it's not going to go constant all of a sudden. Mathematicians are looking at it saying, no, you want it to inflect. Once it inflects, you know you're on the right track. Well, I'm just looking at the curve. Now, you get a few more days, that inflection will come more obvious because your curve's going to start getting that rounding. But I'm just looking at that by eye, and they get started to inflect a bit. So yes, it does suggest, now at the time, when I put this together 12 months ago and thought this is a good little graph, at the time we're saying, oh, it looks like it's effective. Well, we now know that, yes, it was indeed effective. It certainly got it to. All right.